That is NTP. So today we're gonna complete two more protocols related to this one, NTP and Syslog, and after that SNMP. So these three are the management protocols that we use on the networking devices. Later, if time allows, we will complete the wireless also. Okay. Yeah. First one, NTP. So before starting this one, can somebody tell me like why time is really important on the devices? Why time is really important? You set whenever you turn off your mobile and turn it on, sometimes it will ask forward set the time. What is the need of that one? And nowadays they don't, I mean, they don't ask it, automatically they'll get the time. But before, I hope you're seeing like initially they will ask you to set the time. Why is that? Device gets the data in the packet, then that will be arrive on the okay. Mm-hmm. Okay. Not to mismatch. What to mismatch? Mm-hmm. So data time management. Time management. कम्युनिकेशन डाटा जो आप सेंड और रिक्वेस्ट उसका डाटा टाइम दिया जाता है okay. Can take that, yeah. So if you schedule something to send to the client devices, if the what we call time was mismatched means the data gonna not reach at the needed time. Again, it's related to synchronization only, right? Yes? Yes? Any answer? Yeah, like if there's more time, we can keep more data. You mean to say now we are having 24 hours? You mean to say you just need to extend it? Okay. Bharti? Hmm. Yeah. Yes, Abhishek? No idea? Get idea? Shah? Using this synchronization acknowledgement for it are sending and receiving by the device, so it can assign their timing. So if one doesn't send anything, so it can wait for it. So we have the time management. So otherwise it will go in the error state also. Okay, basically what happens, even in your mobile also, okay, uh, logs will be created. Logs, do you know logging? Logs, a record I can say. If you go to the call log, you can get that what is on what date, which I mean on at which time. Okay, this person called me, and how much duration the call went. Okay, so to keep this kind of logs, we want what? The time duration. Sorry, the time and the date. Okay, if the time and date was not there, how you do understand like on which day, at what time he called me, and what was the duration we talked. Yes. So to help to get, I mean, majorly this networking devices, they will have this time just to get the exact logs. Okay, exact records. Why they collect these logs? Any idea? Why they collect the logs? Because they are networking devices. Yes. Continuously they'll be running. Understood? Continuously they'll be running. On what time which interface got down? On what time which interface got up? Okay. On what time somebody tried to access? Okay. If somebody tried to unauthorizedly access the network, at what time and on which date he tried to do that one. So everything will be logged here. So just to have this one, okay, the timing is synchronized with what? With something called NTP server. What is that? NTP server, Network Time Protocol Server. Okay, so you can see here the exact definition. So it is a protocol. It is used to synchronize the clocks of the computers and networking devices over a network. So what it does, with the help of this network, it's going to take the time reference from the NTP server. And we consider that these NTP server are the accurate timekeepers. Okay. And the same time will be given what? Given to the end devices. Okay. End devices like what? The routers, switches, okay, or the computers. Yes. So all these devices I can say. So where it's gonna keep the accurate time is for critical log timestamps and the security purpose and some other network operation purpose. Okay, just to have what? To have this log timestamps and then security protocols and then the network operations. Okay, so I hope you understood log timeskeeping, right? What is logs timeskeeping? The same thing I said you. On what time the device got up. Okay. So one more protocol I said, that is SNMP. What is SNMP? Simple Network Management Protocol. So in that we are going to what do you call integrate all the networking devices into one centralized management or monitoring system. Okay. So on that one we are going to see on which time or at what time, okay, this device got up, this device got down, this interface got down, this interface got up. So this kind of information will be having in the logs there. Okay, that will help us to what? Troubleshoot. Okay, so network is nothing but what? It is majorly about what? Troubleshooting and all. Yes, if something happens, then you have to have what? Something called later we'll say SLA. Okay, service level agreement. So when you go with the SLA, that's a advanced one. You'll get to know later. Okay, so SLA means what? It's kind of a agreement that you will done with the. I mean that can be done with the client. Okay, so they will say that if this device goes down within this time duration, it should be troubleshooted. It should be resolved. Otherwise, we'll start deducting your amount. Service level agreement. So this kind of things will be happening. Okay. So time is directly or indirectly connected to what? Money. Understood? So let's suppose we have these two routers. Okay. So both are running with some routing protocol. Yes. So this router one is synchronized with the NTP server and this is running with its own clock. Okay. And something happens on this interface. Okay. Second router interface and this goes down. Yes. So let's suppose this is in a different location, this is into different location, but both are working for a same organization. Okay. Then this NTP server says that it got down exactly at the 8:19. Okay. But it is having its own clock. What will happen? It says that it got down at the something called 5:10 a.m. Okay. If you take the logs of this one, it says that it got down at the 5:10 a.m. Okay, but it says that just now, just 2 minutes before it got down. So who is going to, I mean, which router's time is going to be referred here? Okay, so client will get confused here. Yes, so that router is showing you at 5:10 it got down, and the first router is showing you at 8:19 it got down. What you guys are doing is why the service is down here. Understood? So just to troubleshoot this one, exactly. If you open both the routers logs, it has to show you the exact timestamps. Understood? So just to have this one, just to have the exact logs, we have to synchronize the time of these networking devices. So it is very important. Okay. And when it comes to security protocols, so sometimes some of the VMs or some of the firewalls, they will be having their own licenses. Okay, they will be running with own licenses, and it is not like they will be continuously running. They will get expired some date. Okay, so on that firewall, let's suppose the license will get expired at, what is the date today? 25/6/25. Okay, exactly on 8/22. But the firewall is what, running with a different timing. Okay, so by that, that is already expired and I'm not getting a alert for that one. Okay, if this is synchronized or synchronized with the SNMP, it will give an alert. This license is got already expired, so just renew this one. Okay, so that firewall is running with a different timestamps. Okay, so that is not sending any alert to the SNMP. Then how the network engineer is going to understand that the license is already got expired? Okay, so just to get the exact alerts on an exact time, okay, we have to have this time should be synchronized. Okay, and for network operations also it will be really helpful. So this is why we are using the NTP, network time protocol. Okay, so this NTP operates on the principle of a hierarchical time distribution, ensuring accurate and consistent timekeeping across a network. Okay, so this hierarchy is nothing but I'll discuss it now. Okay, it has some hierarchy. So how it is going to take the time, accurate time, and how it will be differed from the NTP server. Okay, you can see here the hierarchical architecture of the NTP. So NTP operates in the layered hierarchy called as what? Stratum levels. Okay, remember this one, stratum. Okay, so what exactly these stratum levels are? First one, that is stratum 0. In this stratum 0, we'll be having a high precision time sources like what? Atomic clock, GPS clock, or a radio clocks. So this is considered as a highly accurate time in the whole world. From here only, every NTP server, they are going to take the time reference. Clear? So let's suppose we are connected with a stratum 0, that is a let's suppose GPS clock. Okay, so to this GPS clock, we are connected a one more NTP server. NTP server. Okay, so this NTP server will be in the stratum 1, stratum level 1, and to this NTP server we are going to connect our networks. Okay, let's suppose we connected our routers here. So these routers will be in our stratum 2. So however, you just go farther from that GPS clock or the stratum 0 level, okay, like that the stratum level will go on increases. Okay, so stratum 1, these are the devices directly connected to the stratum 0 sources, serving as a top level NTP server. So this is called as what? Top level NTP server. Yes, and the stratum 2 and lower devices that synchronize time from stratum 1 server and propagate further down the hierarchy. Okay, so just the thing we have to do that. What is that? We have to make these, what you call, routers as a server for the other below devices. Okay, so if you connect one more router to this one, so this will be into the stratum 3. So it goes like that. Okay, so stratum level increase, the distance from the reference clock grows, ensuring a structured time dissemination. The same thing I said you. However, the distance goes from your reference clock, the stratum level go on increases there. Okay. So what is the use of this NTP? First one, high accuracy. NTP can synchronize time with the accuracy of a few milliseconds over a local area network and 10 milliseconds over the internet. So let's suppose your NTP server is inside your network. Inside your network. Then on your devices, okay, the time difference may be of just a few milliseconds. Okay. If the NTP server is inside your network, then the time difference between your system and the NTP server, that may be the difference of few milliseconds. If the NTP server is over the internet, then it may get the difference of few 10 milliseconds. Okay. But that is not a big difference, I can say. Yes. So, and the time sources like NTP servers supports a multiple time sources, and that can select the best source based on the factors like latency and the stratum level. Okay, let's suppose like we have these routers. This is my router which is into stratum 2, I can say, and this is one router which is taking a time reference from this router 1. Okay, and this will be into stratum 3, and we have connected one more router like this. So this router 3 is having time reference from both the routers, router 2 and router 1 also. So what do you think? From where it will take? From where it will take the time reference? From always the higher stratum level. Okay, what is the stratum level of this R1? It is 2. What is about this one? 3. Because there will be a time difference. Okay, this router 3 is always going to get the time reference from the higher stratum level. Okay, if it is having multiple what time sources. Okay, so next, fault tolerance, like NTP detects unreliable time sources and avoids using them to provide error in synchronization. If something happens unauthorizedly, okay, which is unreliable in the network, so that time what will happen? The devices, okay, they are not going to synchronize with that particular device. Okay, if it detects any kind of a malicious things in that what you call device. Okay, and next is what? Security. NTP includes a mechanism like authentication using a symmetric keys or public cryptography to protect against some malicious time manipulation. So here it uses some authentication process. Okay, so majorly it is I don't know, I guess it is MD5. Yes, so it's going to use that one just to authenticate the devices. Okay, next is why the NTP is so important here. First one, accurate time, accurate log and auditing purpose. Okay, why it is used for? First one, accurate logs and auditing purpose. Like time synchronized logs are crucial for what? Troubleshooting, auditing, and forensic analysis. First thing we use is logs for what? Troubleshooting purpose. Okay, we will see whatever the time it got down, why it got down, everything it will be there in the log. Okay, and after that we'll go for the auditing and even for the analysis purpose. Understood? Next, we have the security protocols. Like many security protocols like Kerberos or SSL TLS rely on the accurate time for operations like certificate validation and token expiration. The same thing I said you. Yes, if the certification is getting expired or token is getting expired, that should be alerted to the network engineer. By that, he can renew that one. Okay, if it is getting what you call expired, then it is kind of a threat to the network. How? Because the attacker will always be waiting for the vulnerability. Yes, if he get any kind of a chance to get exploit this one, easily he can do that one. Understood? So that is the reason this will be helpful for us to have a security also. Next, we have distributed system like application in the distributed system like database or cloud services. Those requires synchronized clocks for consistency. Not only in the network operation, in the cloud also they need the synchronized time stamps. Okay. Next, we have event coordination. Like accurate time is essential for what? Coordinating events in industrial automation, financial translation, sorry, transaction, and telecommunications also. Okay, And I hope you know that how it is really important in financial transaction. Am I right? Yeah. So this is what the uses of the NTP. So next we have how the exactly NTP works here. The first thing, here some 4 timestamps will be exchanged, T1 to T4. Just to set the time on my device, it's going to exchange some 4 timestamps. Okay. So time synchronization process. So it uses a port number that is a 123. 123 is a port number which is used by the network time protocol. Okay, which uses a UDP. And here a client sends a request to an NTP server and receives a response with a 4 timestamps. Whenever my system wants to synchronize the time with the NTP server, what it will do? Yes, it has to send a request. How? I just want to synchronize the time with you. Okay, I heard that you have a accurate timing. So can you just give me the reference of the time? Okay. So whenever the request reached at the server, obviously it is going to give the time reference to the client device. Okay. But how? It's gonna exchange these 4 timestamps, T1, T2, T3, and T4. First one, T1, it's gonna originate timestamp. When a client sends the request to the server, that is called as what? T1. Okay. And when this T1 reaches the server, that is called as what? T2. That is called as what? Receive timestamp when the server received the request. Okay. So that is called as what? T2. And against this T2, the server is going to reply back to the client. Okay. So that is called as what? Transmit timestamp. That is nothing but the T3. And when it reaches the destination device, that is called as a destination timestamp, when the client receives the response from the server. Okay. So these are the 4 timestamps will be received in between this server and the client. Okay. So after receiving this response, how the client is going to set its data, sorry, the date and time. Yes, you can see here, using this timestamp, NTP is going to calculate something. It calculates 2 things. One is what? The offset value and the delay. Okay, whenever it sends a T1, with that one, it's going to send its own clock also. Okay, during it is sending the T1, it is going to send its own clock. Just to understand that what is the difference between this my clock and the NTP server's clock. By that it can understand or adjust its own timing. Okay, so you can see here offset the difference between the client's clock and the server's clock. What it said? Offset means what? Its own clock and whatever the response it got from the server. So it will find the difference between them. Okay, after finding the difference, it will go for even calculating the delay. Delay means what? What time it take? What time it take to exchange these T4s? 4 timestamps I said, going to the server and coming back the reply. Whatever the time it takes, so this will also can be calculated. And based on this offset value and the delay, it is going to adjust its time. Okay, you can see here, after that it's gonna do the clock adjustment. Yes, so the client adjusts its clock gradually to prevent abrupt changes that could disrupt the system operation. Okay, so it dynamically adjusts but typically syncs every 64 or 1024 seconds depending on stability. What it does? Dynamically it adjusts or synchronize for every 64 to 1024 second. It is not like it's a one-time process. After every 64 seconds, it's going to synchronize the timing, okay, with the NTP server. Understood? Next, we have some NTP modes here. So we have two modes. One is a NTP server and second one is what? Client. You already know that one. Okay. So what is NTP server? It's very simple. It's gonna give the time reference to the clients. And client means what? It's gonna take the time reference from the server. That is easy. Okay, you can see here. The first one, NTP server mode. In the server mode, a device provides the time synchronization service to other devices in the network. It can be connected to an authoritative time source such as what? GPS clock or a Stratum 1 NTP server. So rely on its own internal network also. Okay, it is not like only it is connected with the authoritative time source. We can give its internal own clock also as a time reference to other one. Okay. And some characteristics of this NTP, the server listen for the NTP server request from the client on the UDP protocol and the port number will be 123. Okay. If the device is getting any request on the port number 123, it can understand that this is a what? NTP request packet. Okay. And it responds with the time information and relevant timestamps. Against this one request, it's going to respond back to the client with what? With the information which is relevant to timestamps. Yes. So the server does not adjust its clock based on the client time. As I said you, during the initial request, the client is going to send its own clocks to the server. Okay. So the server is not going to set or adjust its own time with the clock of this client time. Okay, it will be having its own and the same will be given to the client device. Okay. So next is NTP client mode. In the client mode, the device requests for time synchronization from the NTP server and the client adjusts its clock based on the server's response to achieve accurate timing. What it will do? It will take the time reference from server and it's going to adjust it based on the calculation like delay and the offset. Clear? So some characteristics of this client, the client intimates the communication with the server, initiate, and it sends a request to the server and receive the timestamp to calculate the offset and the delay. Okay. After that, it's gonna adjust its clock gradually. Okay. Now we'll go for configuration. Yeah, what is the time it is showing now? Okay, this is what the uptime now shows that. Okay, what is the date it's showing? March 1, 1993. This is what the internal time, okay, which is always set on these devices. Okay, now what we have to do? First, we have to change the clock on this one. Okay, so how to do that one? Clock set. If I say question mark, it says that give me the current time. How? In the hours, minutes, and the second. Okay, R is what? It's 8:43. Okay, give any number like 30. Okay, after this, if I say question mark, it will ask for what? Date. First, it will ask for date of day of the month and then month. So it is 25 June, right? 2025. Okay, so I set the clock. So if we say show clock here again, shows that 8:43 34 second. Okay, and the date is what? Wednesday, June 25, 25. Okay, now if we check the time duration on these devices, it shows that same. What it will show? Same uptime and the same date, March 1, 1993. Now what we have to do? We have to make this router as a, yeah, currently it is into stratum 1. Okay, so we have to make it as a server, and from the same server we have to, I mean, these two routers has to take the timestamp. Okay, so it's very simple. What we have to do, config t and ntp. If I say question mark, it says that authentication is not required now, just make it as a master. Okay, and after this it will ask for what is the stratum value, so just make it as a 1, just enter, and then you're already having the, what do you call, IP addresses on this one. You can see here, first one on NTP server, you have to make it as a NTP master, and then you have to give the stratum value, and on the client devices you have to say NTP server, and you have to assign the IP address from where it has to take the time reference. Okay, it's very simple. So NTP authentication. Let's go on this one and give the configuration. And if I say NTP server 10.1.1.1, this is a server for the NTP. Okay, and NTP authentication key have to give that is MD5, and this is Cisco. Okay, this the key was of 1024. Okay, so let's go on the second and configure the same thing. NTP server 20.1.1.1. Okay, and then the NTP authentication was MD5 it was using, and this Cisco was the password. What is off? It's a size of 1024. Okay. Now if I say enable show clock, what it says 9/3 Wednesday, June 2025 clock. This is showing now. I think I fast forwarded a lot. Yeah, the same is showing. Okay. I forwarded it a lot. Okay, that's the reason it went to 9. Okay. So 9 hours, 4 minutes, 2 seconds, 950 milliseconds. Okay. It's Wednesday, June 25, 2025. And the same thing you can see here also. Okay. What is 9 hours, 4 minutes, 27 seconds, 313 milliseconds. What is the date here? Wednesday, June 25, 2025. Okay. If you say to NTP associations, you can see here where it is taking from. It is taking from 10.1.1.1. And this means what? Star means system is peer. Okay. And it is configured. Okay. You can see some two signs here. One is asterisk and one more is, I don't know what they call this one. Okay. So this means what? It is configured, and this is system paired with the 10.1.1.1. Okay. And the time reference it is taking from 127.127.1.1. And the statum value is what? It's 1. Whose statum value? NTP's statum value. Okay. So these are the offset value on the delay value. It's nothing there. Okay. NTP. On here also, you can see the same thing. Show NTP associations. It is taking from whom? 20.1.1.1, because I have assigned the IP address the same 20.1.1.1. Okay, the same it is taking from. Yes, so here also you can see the same stratum value and other things, and it is also synchronized with the peer, and it is having configured. Okay, this is very simple. Nothing is there in the NTP. Okay, without this also you can configure that one. You just need to go on the server mode, and you have to say it as what? You are the master for this NTP. Okay, and you have to give this master stratum value, and then on the what do you call client devices, you have to say NTP server, and you just give the IP address of that NTP server, and automatically it will synchronize. If you fast forward it, okay, in the actual scenario, it'll take some time. It'll take some 1 to 2 minutes just to synchronize with the system. Okay. So in this CPD, it's a simulation mode. So that's why I fast forwarded it. You got the time there. Okay, which is synchronized with the NTP server. Clear? Okay. Any doubt in NTP? Sorry, authentication purpose, security purpose. Okay, because Anyone, if you don't give authentication, anyone can synchronize or give their time reference. Okay, they can manipulate the logs and all. Understood? So that is the reason we have to give the authentication key. Clear? Yeah. Next, one more related one, that is a system logging protocol. Okay, it's a bit long and we have to complete that one. Next protocol is what? Syslog. Okay, or you can call it as a system log. Okay, so what exactly it is? It's a standardized protocol used to send, collect, and store the log messages. Okay, from various devices like what? Routers, switches, firewalls, servers, and other networking devices. If you go in the whole, let's say one data center, okay. So each and every device they will be integrated with the NMS here. NMS means what? SNMP. Okay, where on a sitting on a centralized place, okay, you can monitor every device. Okay, with the help of this syslogs, you can have the alerts. You can have the different log of each and every device of each and every second. Okay, the devices they will generate the logs for defined time duration. Okay, it may be 1 second or it may be 10 second. It may be whatever the time duration it will be given to that device. Each and every device has set. Understood? Just to do what? Just for the debugging or troubleshooting and auditing purpose. Why we collect the logs? It provides a centralized way to manage and monitor the system logs for debugging, troubleshooting, and auditing purpose. Okay, so every device they are going to generate this log messages. Every device means what? You can take the switch, you can take the router, you can take the firewall, you can take the server, you can take anything in the networking devices. They will generate what? Logs if they are configured with the syslog. Okay. So what is the key characteristics of this syslog? First one, it's a centralized logging. So logs from the multiple devices can be collected on a central syslog server, making it easier to monitor and analyze the events. What we collect these logs for? Just for what? It will help us to monitor the devices and analyzation purpose later. Okay. Next, it uses some messages, message transmission, like it uses UDP port number 514. It's a default for lightweight and fast communication and can also use the TCP or encrypted communication for reliability and security purpose. Let's suppose like your NTP server is within your network. In that case, it uses a UDP protocol. Okay. Let's suppose your NTP server is in a headquarter and you are sitting in a branch office, and the devices which are collecting the logs here, so that has to be sending their logs to the headquarter NTP server. In this case, it uses what? TCP. Okay, because you know that TCP is secure and reliable. Yes. Next is device support, like supported by most network devices and operating system, making it widely adopted logging standard. It is not like it is restricted to only to networking devices, only to the iOS or something. No, it will be supported by all the operating system and all the devices here. Okay, and it will help us to monitor the devices in real time. What it does? It will help us to monitor the devices in real time. It's gonna enable the administrator to receive the alerts and logs in a real time for immediate action. Okay, as I said you, this NTP, syslog, and SNMP, they are related to each other. Okay, whenever the syslog is generated, that will be alerted on the SNMP. Okay, so the network administrator will be sitting on this SNMP. Okay, we call it as a NMS. You have to work on this NMS only. Whenever you go into the actual enterprise network, they will be having some NMS, the tools on which you have to monitor all the devices. It's a centralized monitoring system. Okay, network management system is it. Yes. So the different companies, they will be using some different monitoring tools. Yes, and the even ticketing tools as well. Understood? Whenever you get any kind of a alert, yes, this device is down. What do you have to do initially when you start working? Okay, they will make you to uh, generate one ticket. Okay, you have to hear this kind of words a lot. Ticket, NMS, monitoring tool. So these kind of things. Yes. So ticket means what? This is done. So for that also we'll be having some different tools like ServiceNow or Jira. I hope you heard about this. Yes, Jira and all. Yes. So these are called as what? Ticketing tools. Yes. So if you just generate one ticket and that will be logged there. Okay, this is the issue. Okay, we have to work on this one. This is just for what? Accounting purpose. You'll keep a log of that one. So at this time, this device got down, this interface goes down. Okay, whatever the troubleshooting process you will be doing, you will be maintaining that one. Understood? That's for the ticketing tool and the monitoring tool. Yes. So NMS, yeah, that's what you are going to get the alert on NMS, and again based on the severity level, you are going to take the action here. Okay, this is not that important. Okay, we can resolve it later. So it's totally based on how much severity level you have given on that. So later we'll get to know what is the severity level and the facilities we have. Yes. Next, categorization. The same thing I said you. Syslog messages are categorized based on what? The facilities. Facilities means what? The source or a type of a process, where it is coming from where the log is coming from or alert is coming from. Whether it is from the operating system, I have to take the immediate action. It is just what? A fan module is down or a power source is down. Yeah, we can see it later because for the fan module or the power module, we'll be having the redundant ways. Okay, it is not like we'll be having only one power module or only one fan module. Okay, why fan module or power module is really important in the network devices. Fan module is just to keep the cooling purpose of that network device, and power module is obviously you need the power to that one. Okay, so like that, can you see that power module there, the black color? Okay, that is like that. Nowadays we'll be having 4 power module redundant modules here in routers or switches or in advanced networking devices I'm telling about. Okay, I mean if one fails, then immediately the power goes from the other one. Okay, so like this. And the severity level means what? Like the priority of that message. The same thing I said you. It is really emergency, immediate action it needed, or it's just a debugging purpose. So based on this severity level, you can take an action on that one. Okay, so like that, it is going to categorize it. Understood? So next we have like how exactly syslog works here. So first one, it will generate the logs there. It will generate the logs on the device. You can see the device will generate the system or a event messages like interface going down or a authentication attempt or a software crash. This kind of examples. These are the examples. So this kind of a logs will be generated on the devices there. Even I can say it as a alert. Yes. So after generating the logs, it's gonna forward it. It's gonna forward it to whom? Logs sent to the syslog server or stored locally. You can store it either way. Okay. You can send it to the NTP server also, or you can store it locally. Whenever you require it, you can access it. Yes. So administrator, he has to configure the device to forward specific logs to the remote server as well. The same thing I said you. In a scenario where you're working in a branch office, okay, and your higher authority that said you to send all the logs to the headquarter. Okay, because we are having the NTP server in the headquarter, you just send the same to the headquarter NTP server. So like that, you have to send your what do you call NTP logs to the headquarter, not NTP, syslog server. Okay. So that can be configured with the help of this administrator. Yes. So after forwarding this, after forwarding the logs, that can be processed. Like how it is processed, you can see here. This syslog server processes, categorizes, and stores the log separately. How it categorizes? As I said you, it will see the facility, it will see the severity level. Okay. If the severity level is very high, it will keep it up the above. Okay, because they have to be taken action very immediately. Okay. And in advanced syslog servers, they can filter out the logs, trigger alerts, and generate even the reports if you require it. Okay. And after the processing, they will analyze it. Like logs are reviewed to identify issues, monitor performance, and comply with the regulatory requirements. So nowadays, the AI and ML is totally integrated into the network here. So whatever the solution you need, that will be giving you. Okay. So this can be done just to resolve this issue. Okay. This is how the AI is helping us in network automation. Okay. No. Okay. So components of this syslog message. First one, a syslog message typically includes timestamp. What is timestamp? I said when the event occurred, at what time, on which date it occurred. Okay, this is what the content of that alert I'm talking about. First one, it will say that at what time, on which date this event happened. Event means what? The interface got down, or somebody tried to access unauthorizedly. So this kind of alerts. Yes. Next is from where it came, like host name or IP address. The device that sends or generate a message. Okay, from where I got this message from. Obviously, we are going to see it from the with the help of their IP address only. Okay, and facility, like what is the source or a type of that log messages, whether it is from a local operating system or something else like that. Okay, we have some facilities like you can see here. Okay, so these facilities will be given here, and then the severity level. We have some 7 severity levels here. Okay, we are going to discuss about later. So how important that message is, how we are going to prioritize it. So based on this severity level, you are going to decide that one, and after that, the message content will be there. Like what? The actual log or event details will be included into the syslog message here. Okay, understood. Next, we'll see the facilities and the severity levels. I'm not going to read out all this. You can read it later. And once you read it, it will be understandable. Okay. You can see here. I'm just recording this one. Hmm? I think I already sent you, right? Because this one, everything is there. Next, syslog facilities and severity level. So facility is nothing but what? It's going to categorize a source message. For example, kernel or a mail or a system daemons or a local use like local 0 to local 7. What do you mean by kernel? Yes, Murali, what is kernel? Are you sure? What is kernel? Mm-hmm. Yeah, it is in the operating system which will help the Like it's kind of an interface between the software and the hardware. Okay. Huh? So it is related to kernel or something mail or something system or a local 0 to local 7. We'll discuss what is that local 0 and local 7. Okay. And severity level means what? It indicates that urgency or a criticality of that message. How urgently we have to take the action on that alert. Okay. Is it very important or it can be seen later? Okay. So based on that one. So as I said we have some 7 levels we have in the syslog severity. Okay. We call it as a severity level 0 to severity level 7. Okay. Starting with emergency, ending with the debugging. Okay. Now we'll see syslog facilities. So facilities are used to categorize the messages generated by the device. So each facility represents a specific type of a process or a system component. Like what? If the facility code is 0, that is related to a kernel message. Like this, you can see. 1, it is user level message. 2, mail system. 3, system demands. And 4, it is related to security or authorization. Okay. And 5, it is a syslog directory. And then 6, line printer system. 7, network news. Or 8, it's a subsystem. And remaining 16 to 23, they are like a local use. Local means what? For networking devices like Cisco routers and switches, local facilities will be given. So that can be configured by the network administrator, like local 0 to local 7. Okay. So these are those local 7. You can read it later. Okay. And even you can get the different application or the examples of this local 0 to local 7 in Google also. Okay. Next we have severity levels. As I said we have how many severity levels? 7 severity levels. Okay. So severity level define the importance of criticality of a log message. Okay. These range from emergencies to debugging. Okay. What is this? If the severity level is 0, that means what? It's emergency. The system is totally unusable. Okay. So I'll try to explain this. And 1 is alert. That means just immediate action is needed here. And 2 means what? It is critical condition. And then 3, it is just to show you an error condition of a system. And then 4 is for warning. And 5 is for notice, like a normal but significant condition. And 6 is nothing but just an informational message. Okay. And 7 is what? Debug. This is used for what? Troubleshooting purpose. Okay. So in a scenarios like what? When we can get the emergency, when we can give the severity level as the emergency. You can see here. This is the highest level of the severity. This indicates that the system is in a critical condition and may be totally unusable. Okay, we stop totally working. Okay, in that condition, we can get the alert as what? 0. Okay, so it often refers to the situation like what? Complete system failure or hardware malfunction, or even you can say critical system error that prevents the system for functioning at all. For example, you can see here kernel panic or a system is completely down. In this case, the severity level you will get in that message as a 0. Okay, and after that we have a alert. So here action is needed immediately. So this severity level represents a serious condition that requires immediate attention, but do not completely stop the working. Okay. For example, like it includes a severe hardware failure or condition where immediate intervention is required to prevent the further damage or service disruption. Okay. When we use the alert here, when you use a number called 1, it is totally not stopped working, but it need a immediate action on that one. For example, a critical system resource is running out, like what? Disk space. Okay, that can be replaced very early. Yes. and you can make it free if you want. Next is what? Database service failure or a security breach is happened. These kind of things, what? They need a immediate intervention that could be taken here. Understood? So next is what? Critical. So it indicates that a serious condition that could lead to failure, but it isn't necessarily an immediate emergency. You can see here a hardware component failure, just like what? Disk failure warning. This is not affecting the current operation, but it should be taken care immediately. Okay. So it may require prompt attention to avoid more severe consequences in a future. So, but the system still be operational. Okay. So in that case, you can get this one like application crash or network connection issues. In this case, you will get the severity level as a 2. And next one is error. So it represents a non-critical that needs not to be addressed, but the system is still operational, but some of the functionalities or services has been affected or even failed. For example, failed login attempt or a service or application failure that doesn't crash the system, and file permission issues. So this kind of condition will get the severity level as a 3. Okay. So like this, we have warning where it's going to give you a warning about disk space usage is getting high, but not critical. So here deprecated function being used in application or a low memory warnings. So in this case, we are going to get a severity level as 4. And next we have notice, where it will just notice you like this level represents a normal but significant condition. So these messages are not errors, but they are noteworthy events that might require attention or observation, and they might be informational message indicating a significant change in the system state or a configuration. For example, system startup or a shutdown logs, user login or logout messages, and network interface changes like interface is going down or interface is going up. So these kind of messages you will get in a severity level as a 5. Okay. Like that, we have next informational and the debug. Information is nothing but what? A user is successfully logged in, or a process start or a stop notification, or a system resource usage statistics. Okay. In this case, you will get a number value as 6. And the last one is what? Debugging. Like detailed application logs during the development just for the troubleshooting purpose. And low level debugging network of the network activity or even the internal state is in a services. So in this case, we use this number value as a 7. Okay. Okay. For this, I will take a server here. Desktop IP configuration 30.102. Okay. Send the IP address. So let's go to the services. Can I just find a syslog here? Here it is. Okay. That is on. Then go to the router here just to start the logging. Okay. So exit, and the configuration is really easy. If you see here, first thing what you have to do, we have to start the logging. Okay. Router logging on, and then you have to say logging. If I say question mark, it will be having a trap. Trap means what? whatever the severity level I said you. Okay, so here it will be having only one, that is debugging purpose. Can you see severity level 0? Okay, so we have debugging, and then we have to say uh, logging into where, in which server, that is 30.1.1.2. Okay, you just send your logs to what, 30.1.1.2. That's nothing but our syslog server what I have connected here. Okay, just say enter, and after this you have to say how it should be. It should be containing timestamps and even the date and date in and the time in milliseconds. So everything will be given here. Okay, so service timestamps. After that, you have to keep the logs in the daytime in a millisecond. Okay, that is it. Exit. You can see there now it started giving the time also. June 25, 9:36, 8. This is 36 is what? Millisecond. Okay. Now let's go here and we'll do one thing. Let's make this interface 0/1 as down. So config T interface greater than 0/1 and make it as a shut down. Okay. Is it showing you giving you time and date? Okay. Let's go to the server here. Is it having? Is it collecting this logs here? Yes. Can I see the time and date? Yes. It's showing you 6/25. I mean 25, 6 month, and the 2025 is the year. And what is the time here? 9:36:40 AM. I got a message from whom? 30.1.1.1. Like what? The interface. Okay, that is 0/1 got changed or changed its state to down, and even the log or line protocol is also got changed that to down. Okay, so like this kind of messages or logs will be getting in the timestamps. Okay, or syslog I can say. So let's crossover. Why to crossover? J. Let's check. Okay. Yeah, let's make it again no shutdown. It got up. Okay. Do you think again we got one more event there? One more log there? Yes, we have. Okay. You can see here at which one? Yeah, this one. Okay, 9:38. We got one more, that is up down. So it just changed state to up. Understood? So this is how to enable the logging on the device. Yes. If you see, that's it. Okay. Yeah, any doubt in syslog? Any doubt? These are management protocols. Okay. Uh, it is not like nobody will ask about this management protocol in interview. somebody they will ask like what is NTP and why this syslog is used for, what is the use of this SNMP, they will ask you. Okay, so don't ignore this. The next one more related the protocol I said, which one? SNMP. I think almost I said about this one, SNMP. Why we use it for? It is network management and centralized monitoring purpose. Okay. SNMP stands for what? Simple Network Management Protocol. Okay. Where it is widely used for use protocol in the network management for monitoring and controlling devices within the network, which is majorly used for what? Monitoring. And nowadays we can configure also on the same SNMP or NMS. It will allow us to configure the devices remotely, and it operates at the application layer and enables the administrator to gather data, configure the devices, and monitor network performance efficiently. Yes. So some of the functions of this SNMP. First one is a device monitoring. SNMP enables administrator to monitor the status and performance of the network devices, just like what? Routers, switches, servers, and printers. By retrieving real-time data such as metrics CPU usage, memory utilization or disk space, and the interface status can be collected with the help of this syslogs on the SNMP here. Okay, as I already said you, each and every device will be integrated with this NMS. Okay, so this will help us for what? Centralized device monitoring, and after this it will help us for what? Fault detection and alerts. SNMP can detect and reports of faults or abnormal condition in the network. Just like what? Failed interface or a high traffic on a link. Every time it's gonna show you. Even I have shown you the logs there, right? The interface goes down, interface got up. Yes, says this kind of alerts will be given here. And the traffic is, if the traffic is very high on a particular link, so that can also be alert to the network administrator. Okay, on the NMS tool asset. So traps and notifications, so these are really important when it comes to SNMP. Okay, based on this only it is going to get back you an alerts, or if you want to configure that one, the traps are only will be helping you. Understood? So these devices send some SNMP traps like asynchronous alerts to notify the management system of a specific event or a changes. Yes. So here it proactive alerts enable administrator to respond to issues before they escalate it. So based on this alert, what the network administrator can do, he can immediately take an action on that one before it can be get escalated. What do you mean by escalation? What do you mean by escalation? You worked right? In which level? Level 1 or level 2? How it is? Level 2, right? Do you know the escalation? I don't know. Okay. Mr. Bosu, do you know what is escalation? Escalation means what? Like if anybody, anything trouble comes, okay, and being a L1 engineer, okay, initially nobody will give you L2 or L3. Yes. So you have to start with the L1. And if it is not possible by you to troubleshoot that one, to resolve that issue, you are going to give it to your higher authority like L2. This is called as escalation. Okay. So before escalation, you have to be resolving this issue. Understood? So here also, before escalation, the administrator has to respond back to the trouble what we got here. Okay. So next is configuration management. Like administrator can be, he can use the SNMP to modify the configuration of the network devices remotely. For example, enabling or disabling a specific port on a switch, or adjusting the quality of service setting on a router, and update the firmware or apply patches. Okay. So this kind of configuration can be done with the help of this NMS. Okay. After that, performance management, like it can collect the performance data over the data to analyze trends and plans for the future capacity. And like just like what bandwidth usage or a packet loss or latency, which will help to identify bottleneck and optimize resource allocation. Okay, for example, on a particular link, you have given some 3 Gbps bandwidth, and it is totally not utilized. Only one Gbps is getting utilized. So after collecting this data, the network administrator can analyze that. So yeah, I have given 3 Gbps of bandwidth here. So only 1 Gbps is getting utilized. So how can I use this remaining 2 Gbps? Okay. So that can be used with the help of, or analyzed with the help of this NMS. Okay. Or SNMP by collecting the logs here. Yes. Next is inventory management. What is inventory? What is inventory? What is inventory? Huh? Storage. SNMP can provide the details about the connected devices, including their hardware specifications, software versions, and installed modules. Like you have this switch. Okay, inside this, what operating system you have? Which model is this one? Okay, how many ports it has? Everything it will be having in the inventory. Okay, so this data simplifies the asset tracking and lifecycle management. And the last one is scalability. Like SNMP supports managing large network by centralized monitoring and configuration tasks through a NMS, network management system. Okay, now we'll see some of the components of this NMS. So first, the three things we have to have here. First one is a managed device, and then we have to have a NMS, and then the MIB. It's a database. Okay. First one, managed device. Yes. So here, the devices like routers, switches, servers, and printers that have SNMP agents installed in it. So they will be helping us to collect the logs and give it to the NMS. So they are called as what? Managed devices or the agents. Okay. So these agents collect and store the data about the device's operation. Clear? And after this, collecting this data, it is going to forwarding to the NMS. It is a centralized system that communicate with the SNMP agents to gather and analyze the information. Okay. For example, the tools like SolarWinds, Nagios, or PRTG. Okay, these are majorly used NMS tools. Okay, so you can study this. Okay, SolarWinds, Nagios, or a PRTG. Yes, I think one recently Networkers Home uploaded one video about this. You can find it. Okay, sorry. Yeah, monitoring tools. Okay, NMS tools. Okay, like Splunk and PRTG, SolarWinds. Okay, they have uploaded a video of Ajay sir. Okay, you can watch that one. Yes. So next is MIB. It's a database that defines the structure of the data collected by the SNMP. What it will do? It is the total collection of that data which is collected by the different devices. It organizes the data in a hierarchical structure, and those MIBs, they'll be having their IDs. They call it as a OID, objects identifier. Okay, so I'll show you what is this OID and MIB. And this SNMP is having some three versions. SNMP version 1, this is the original version. Now, just because of the robust security, okay, it is not being used. Next is V2C, I mean version 2C, which was introduced in the performance improvement of this version 1, but it uses some community string for security, which is still a weaker one. So that is why it is not being used now. So the latest one is what? Version 3. It provides a enhanced security with the authentication and encryption, making it the preferred choice for modern networks. Okay. So we have some messages here like read, write, notification, and a response. So read is nothing but what? Like a message sent by the NMS to read the information from the managed devices. For example, if you want to read any message from the router or a switch or any kind of a firewall, something. Okay. During that one, we will get some messages, just like what? Get bulk or a get next. Okay. With the help of these, the read message will be executed. Okay. And if you want to change any kind of configuration on the devices, then it uses what? Write. Okay. Where again it will be sent from NMS to the managed devices. So sent by the NMS to change any information on the managed devices, just like what? Change any IP address on the device. Again, it uses a message called set. I'll show you both get and set. Next is notification, like a message sent by the managed device to alert the NMS to particular event, just like what? Interface going down. Yes. So here it uses some two messages here, trap and inform. Okay. So these two are the messages which is used by the notification just to alert the network administrator on the NMS. Clear? After that response, these are the messages sent in response to a previous messages or request. Okay. So this is something about the SNMP. Let's go and do that one. Okay, I'll take one. I'll just remove this. Otherwise, again, I have to assign one more IP address here. The configuration is really small. You just need to give only this one or this one. Okay. SNMP server community. You have to give a community string and then you have to say read only or read write both. Okay. And this one, authentication and all, you can do it later if you want. Yeah, SNMP server, if it has a question mark, it is having community. Okay. So in that community also, you have to give a community string. Okay, let's give it as a Cisco. And after this, it will ask you like, you want to make it as only read or read write both. I mean, you want to get only message from the device or managed devices, or you want to control them. You want to change any kind of configuration on that also. Okay, so let's give it as a RW. It is both read and write. That's it. Okay, so go to this PC now. So close this, and here you have to go to the MIB browser. To go what? To go to the MIB browser and go to the advanced, and here you have to give the IP address of that one 30.1.1.1. Okay, the port number it uses 161. And what was the read community and write community? What I have given? Cisco and Cisco. Both are Cisco only. Okay, you can check the version here if you want, and then just say okay. Done. Now let us open this tree of the MIB. Okay, currently I'm not using any switch, so I'm using only router. So just open the router tree here. Okay, now just go to system descriptor. Can you see OID here? You can see the different IDs for different MIB. Okay, for description, system description, you will be having some different OID. For this one, different. For this one, different. Everything will be different. Okay, so if I go to the system description, and you can see here get bulk and set, we have the same messages are shown you. So just say get now, just say go. Here it will show you what is the description of that router. Okay, you can see what router is that. It is a 2900, see 2900 Cisco router here. Okay, and if I go to the uptime, just say go. It says that it is up since 9 hours 58 seconds. Yeah, 8 millisecond. Sorry, 58 minutes and 8 seconds here. Okay. And system name. What is this system name? It's a router. It's what? Router it is. Okay. No, location it is not currently connected with that one. It will not show you. How many interfaces it has? 4 interfaces, including VLAN 1. Okay. Next, if table, if you open this one, you can see here index the 4 interfaces what we have. Okay, description, these are the 4 what interfaces what it has: gigabit ethernet 0/0, 0/1, 0/2, and VLAN 1. Okay, after that, what is the type of that? Copper gigabit ethernet. Okay, after that, the MTU. What is MTU? Maximum transmission unit. It can transmit the data up to 15 MTUs. And then the speed will be obviously giga. Okay, you can see there giga. And then the physical address, it's nothing but the MAC addresses it will showing you. Okay, and the admin status, how many interfaces are up and down? You can see all the interfaces are up there. Only VLAN is down. Okay, operational status is also same. Down, up. Now what we'll do? We'll just go to the system name and try to change that one. So how to change that one? Just go to set, and it will be having the OID, and you just change the data type here. What is the data type? It is a octet string. Now just give it as a R1. I'm just changing the name of this router. It is already named as what? Router. I'm just changing it to R1. Okay, done. Did it change? Yes. Even if you go on the router also, now it is showing what? Router. Okay. If I hit enter, it says that R1. That means being on the NMS, we can change the configuration of these devices or the managed devices. Understood? So this is what the CPT permits us to do with the NMS, and that's all I have shown you here. Clear? Am I clear? Okay. Any doubt here? Great. So we'll just stop it here today. Okay.